group of people to have access to these applications. Auditing is simple. It's simple to do. It's built in Asphalt, and it's useful if you have a large data set and you're going through all those various roles and 6 people have touched the data before it gets to you. At some time, something's wrong. Now you want to know where did it go wrong. Then you can go back and you can see exactly who touched the data and what they did to it. Model deployment integration is easy. Usually this is a problem. If you're working on a data science project, a bunch of people, data modelers are sitting in the room, they build a model, and then that model is handed over in some form to application developers who have to deploy it at a client. With this platform, you can just wrap a REST API around your model and publish it on the web, just like that. And it's available for your own applications or for other applications if you want. And then the whole thing is able to scale very easily. Ecosystem, just the fact that they're partnering with open source projects. They're contributing enormously to Apache Spark, primarily financially. I don't know to what degree they're contributing code, but lots of money going into that. And then the data first method. Locally, South Africa, especially, this is significant because we are a bit behind the curve, no doubt about that. And for companies to be able to use whatever IBM is providing, they must be at a point where it makes sense to use that technology. And IBM recognizes that the way to deal with that is to help companies grow, take their hand and move them along to the point where they can make use of that technology. So, and they formalize that process. So go to the company, sit with them, do a briefing, a vision, do a discovery workshop. What do they have? Where do they want to end up? Do a design with them, validate it against their goals, and then implement the thing. That's up to the client, of course, and then help them maintain it if there are issues. That's what IBM said. This is what I took away from it. So I attended about 24 sessions out of those 2,200, and this is what I got. Cloud is big. It's not a surprise maybe, but I don't think we're really feeling it quite here yet. But over there, it's a mad rush. I don't know if it's really always. I mean, there's hype. There's lots of hype, but companies are really running to get as much of their data, as much of their applications on the cloud. ADI economy is big, so companies make available bits of functionality via the web, and you build an application that just call these bits. You can use IBM. You can do speech recognition with Google. So you talk to it, get some text back, and you send the text to IBM Watson to process it further. So the user isn't aware of it, but in the background you can mix and match all over the show. Deep learning is big. DevOps, who knows the term DevOps? Are they right? And do any of you have a role description in your company, DevOps? Or is it just something that you look at? There's lots of movement there. Container technology is big. Who's using containers in development? Not yet. Docker, two hands. Okay. React. New generation of analytics technology is exclusively open source. For many, many years, IBM and SAS dominated the analytics, predictive analytics world. And that time is over, if I'm allowed to say that. Open source is really working. These days, if you're doing machine learning, you're working with Spark, you're working with Jupyter, you're working with TensorFlow, all open source tools. IBM recognizes this, they embrace open source, and they also, as I said, supports we can mix and match approach to cloud services. At the conference, there was one session I happened to notice where there was a Google co-presenter at IBM conference. Not something you see often. And so what does IBM bring to the table? They're not bringing new core technology, maybe some of it in Watson. They are bringing integration and interoperability. The aim here is to provide tools. They're not offering products, they're providing tools to their business partners. And the idea is that business partners build solutions, they do the marketing, and they provide support. cloud migration is a process. It doesn't happen overnight. For a long time, we'll be standing with feet in both worlds. And again, IBM recognizes this, and they advocate a hybrid approach. But this is not easy. If you want to move to the cloud, it takes specialized skills and lots of thinking beforehand. And the result of this is that many businesses are confused. Even in the US, people that were there don't quite know. They know the cloud is there, they should do something about it, but don't quite know what. And therefore, solutions have to be designed around the clients and their needs. I've seen this many times. Somebody get a bright idea, spend 2 years developing, and then try to sell it, and nobody's really interested. That interaction is vital, and it's becoming more and more important. So what's the problems if you ask people there? Security, architecture, and how to migrate. And the first one, security, is interesting because it seems to be always the first thing that comes up, and I think it's a red herring. I think in many cases, the security that a cloud solution offers is significantly better than you could do yourself. For the next 2 or 3 years, if you're moving to the cloud, if you're going to implement cognitive solutions, the time frames and the cost is critical. The world we're right in now is different from the one we're going to be in 6 months. It's moving that fast. So if you're planning to release something in 6 months, you should design for that. I'm going to skip that bit. It was an extra bit about cloud transition strategy, but not today. I'm going to go right over into something quite different. Let me just start that up. There's a company in Los Angeles called Agile Innovations, and they've been working on an AI system for about 15 years now. And I visited them, and I was very impressed with what they're doing. So I asked if I could show an internal demo that they made here, just to give you an idea. Because what they're doing, as far as I know, there's nothing else in the world that compares with it currently. They've been at it for 15 years. About 100 person years has gone into the system. They're a team of 10 people. And the bulk of that development is for a natural language parser, to be able to make sense of natural language. The company, I just want to show you what they look like. Guy at the top left there is Peter Voss, and it's his company and his architecture. And then there's 9 other people that's currently working on the project. 3 of those people, 3 at the top, are doing programming. The rest they call AI psychologists. And they're working in a language they developed internally to build up the system. Again, just a disclaimer, I have no formal relationship with this company. I'm just bringing it here because I think it's interesting. So it can do complex text comprehension. It can really understand remarkably complex sentences. It manages a conversation if it realizes that it doesn't know something, or that what you're telling it is ambiguous. It asks for clarification and extra information. It's got short-term and long-term memory. It's got an internal representation of what it knows that you can access, that you can look at and make sense. So it's not like deep learning where it's all hidden and strange. You can see exactly what's happening inside it. You can answer questions. It does inference, semantic inference. It can do deductive and inductive reasoning. It learns interactively, including one-shot learning. Again, very different from deep learning. We have to have tens, hundreds, thousands of examples. Here we tell it something once and it knows it. And you can tell it to learn stuff in natural language. So something like, if I receive email from Jacques, then read it out loud. You can also, this is experimental, but you can also tell it about grammar rules. Well, this is not true, but you can say something like a noun is always preceded by an adjective. And then it will incorporate that automatically within its parsing structure. So I'm going to show you a demo. And the demo here, so this is it's a general system. For the purposes of this demo, it's been cast in the form of a conversational agent. And specifically, the application is a virtual assistant for somebody that's getting older, that needs somebody to help them manage their life.
Good.
Hello, Bill. I am Igo, your new helper. As I get to know more about you, I'll get better at my job. Can you tell me something about yourself?
Like what?
Oh, like about your interests, family, profession, or where you've lived.
Well, let's see. My favorite wine is Etna Rosso, and I don't like white wine. More seriously, I have 3 grown children.
The first part of this is just dumping lots of information into IGO, and then in the latter part you'll see us pulling that out, that information in different ways.
My daughter Sarah has 2 boys. James, my son, has a 10-year-old girl. And my youngest daughter June is single.
Where do they live?
June lives in Redondo Beach, and Sarah is in Austin. James is in the Bay Area with his daughter.
Where is Redondo Beach?
In Los Angeles.
Bill just received an email from his son James.
Bill, you just got an email from your son. Would you like me to read it?
Roger.
I don't know what Roger means.
Roger is the same as yes.
Got it. Here is the email. Hi Dad. I'm on my flight to Chicago and thought I'd shoot you a quick email. I heard that you had fun in Maui with Lily. Hey, Katie just won a reading competition at school. You should congratulate her. Did you hear that June has signed up for a Tough Mudder event? How crazy is that? I've been meaning to tell you, I just bought a 20-foot fishing boat just like the one that you had. Its top speed is 14 knots. Katie says it's super fast. It also has the same 50 horsepower Evinrude engine. I sold my 18-foot sailboat to my neighbor because it's too slow. Oh, remember, the fishing trip I'm taking you on is in June. We should also plan for the hiking trip. It'll be in late July or early August. Sarah told me she bought you a Fitbit. The default 4,000 steps goal should be perfect to prepare for the hiking trip. Love, James. Who's Lily?
Lily Lane is my girlfriend.
Bill is calling his granddaughter Katie. Igo is listening.
Hey, Grandpa, what's up?
Hi, Katie. Nothing much. What have you been up to?
Well, Dad told me he used to go to this teeny UC in Santa Barbara, and he took me there last week. I want to go to the same school when I grow up.
Good choice, Katie. That's a great school. Hey, I heard that you won a competition. Congratulations.
Thanks, Grandpa. The story I read was about some men who got rescued from a remote island. Can I read it to you? I think you'll like it.
Sure.
Notice now, we're now jumping from current context into some other context, into a story. And IGO keeps track of that. It recognizes that it's a sort of different reality.
Would love that.
Okay, here it is. The men rescued in this tale of 3 castaways were not named Tom Hanks or Gilligan or Robinson Crusoe, though they might as well have been. In a scene straight from Hollywood, a U.S. Navy plane spotted the word help spelled out in palm fronds on a beach. It was on a deserted island in the remote Pacific. The 3 men had been missing for 3 days. A wave had overtaken the skiff they were traveling in. The men were found waving their orange life jackets on the teeny Micronesian island of Vanadik. The island is several hundred miles north of Papua New Guinea, officials said April 9th. The men's families reported them missing April 5th after they failed to show up at the Micronesian island of Wino, where they were traveling from their home island, Pulak. 2 cargo ships searched a combined 17 hours for the men as part of AMVER. It is a Coast Guard voluntary search and rescue program. With AMVER, rescue coordinators can identify participating ships in the area of distress and ask them to help.
Katie, you're a beautiful reader.
Thanks, Grandpa.
That reminds me. I got a new computerized companion named Igo. It can talk and read almost as beautifully as you. Do you want to ask it some questions to see what it learned?
Okay, sure. Let me think. Igo, what did a U.S. Navy plane see?
The word help, spelled out in palm fronds on a beach on a deserted island in the Pacific.
Whoa, you did understand the story. Where is the island of Benedict?
Several hundred miles north of Papua New Guinea.
What is AMVER?
A voluntary search and rescue Coast Guard program.
What can rescue coordinators do with AMVER?
Identify participating ships in the area of distress and ask them to help.
Pretty cool, Grandpa.
I know. Hey, did you hear that your Aunt June will be participating in the Tough Mudder?
Just answering those questions. So one way to do it is just to go back and scan through the text and sort of make a guess. This is not what's happening. IGO is really an internal representation. It's internalized those facts. It does inference on its internal representation and turns it back into natural language.
No, what is that?
Igo, tell Katie and me about Tough Mudder.
I don't know that. Let me look that up.
Igo is reading Wikipedia.
Tough Mudder is an endurance event series that was designed and created by a British Harvard Business School postgraduate and a former corporate lawyer and tests mental and physical strength.
What do participants do?
Attempt the 10, 12-mile long military-style obstacle courses.
What do you know about the obstacles?
The obstacles often play on common human fears such as fire, water, electricity, and heights.
Wow, where did you get that?
Wikipedia.
Bill's business partner calls with a meeting request.
Bill, let's go over your commissions this afternoon. Your total sales amount for this month is $88,520. Meet me at 3 p.m. at the club on Alameda Street, okay? I'll be there.
Incoming call from Sarah.
Hey, Dad. I found your lucky golf club. It was in the attic behind the Lazy Boy. I'll bring it along next time I visit.
That would be nice.
Gotta run. Talk to you later.
There are 2 clubs now. There's a golf club and there's a meeting at the club. And I can know those are not the same thing.
Bill talks to Igo.
Igo, I'm meeting James shortly to discuss my commissions. Where is the club?
On Alameda Street.
How much was the sales amount?
$88,520.
Can you calculate my sales commission?
I don't know how to calculate your sales commission. Can you teach me?
Multiply the amount by 12.5%. That's it.
Got it.
So, calculate my sales commission.
$11,065.
Calculate my sales commission on $10,000.
$1,250.
Awesome. You are a quick learner. By the way, my daughter from California is coming to visit me.
When is the visit?
Next week. When is the trip?
Which trip?
The hiking trip.
In late July or early August.
Thanks. Oh, Igo, please order 2 bottles of my favorite red.
Sure, 2 bottles of Etna Rosso.
Actually, make that 3.
Okay, I'll order 3 bottles of Etna Rosso.
Later this evening, Sarah contacts Igo privately.
Igo, how many steps did Bill take today?
1,800.
Is he already asleep?
No, awake.
Please ask him to call me.
Okay.
Igo contacts Bill.
Please call Sarah Bill.
Thanks. I didn't know you took messages, too. I'm impressed. Let's see how smart you are. Does my son have any children?
Yes.
Sarah is to Bill as Katie is to whom?
James.
Why did you...
Analogy, crude analogy, but it's just...
James sell his boat?
Because it is too slow.
Who has it now?
James's neighbor.
Who used to own it before?
James.
Is it longer than the fishing boat?
No, shorter.
Is the 50 horsepower engine part of the fishing boat?
Yes.
Is the fishing boat super fast?
Yes.
Who told you that?
Katie said that.
Igo, don't believe everything Katie says.
Okay, I will be careful with things Katie says.
What speed are super fast?
It keeps track. Every time it learns something, it stores the source too, and it keeps track of the reliability of all sources. So if it has conflicting information, it looks what information comes from the most trusted source.
Fast boats.
43 knots.
How fast is the fishing boat?
14 knots.
What did my granddaughter win?
A reading competition.
Does Katie plan to go to USC?
No, to this tiny UC in Santa Barbara.
Where did Sarah find the club?
In the attic, behind the lazy boy.
Who is coming to visit me?
June.
Which wine don't I like?
White wine.
What did Sarah buy me?
A Fitbit.
What will Sarah buy?
I don't know.
Who is lip...
It has an idea of time, something has happened or it will happen. It's not just a single fact. So one way to store that is Sarah bought him a Fitbit, so Sarah, Fitbit, bought, Bull, sort of in a single data structure. But it would have no idea whether this has happened or going to happen. But it keeps track of time as well.
Lily's boyfriend.
You.
Does Tough Mudder test spiritual strength?
No. Mental and physical strength.
Igo can also do reminders and lists, play music, control home automation, all in natural language and integrate it with the rest of its knowledge about family and friends.
Right. Just going to quickly give you an idea of the architecture there. So natural language comes in, and Igo at the moment has one sensor, which is this natural language event queue. Then there's a natural language parser, which is really the most complex part of the system at the moment. There are many stages there. I'm just going to lift out one or two. So one of the things you want to do which is difficult, is pronoun resolution. So if you say he, she, or it, who are you referring to? So it keeps track of context. If you've mentioned several people before, it works out who's the most likely one at the moment you're talking about. Clause attachment resolution. If you have long, complex sentence, I'll show you an example here. So I say I shot an elephant in my pajamas. That's ambiguous. It can mean one of two things. It means while I shot an elephant, I was wearing my pajamas, or I shot an elephant that was wearing my pajamas. And that sort of ambiguity pops up all the time in complex sentences. And they manage to handle that quite well. And yeah, so and that grammar rule system, those AI psychologists, the 7 of them, they are working exclusively in there. And they have a language in which they represent grammar rules. So stuff like this word becomes only occurs after that type of word, but only in these circumstances. That's currently, it's 100, maybe even over 1,000 different rules. And this is one place where the system, I think it's an issue. Those hands, it's incredibly labor intensive. Those rules are all coded by hand. There's a weight assigned to each rule by hand. And it's brittle. If you fiddle with that too much, then there might be something that doesn't quite work anymore. You add another rule, you have to adjust the weights by hand. So lots of effort going into that. But then as Igo goes through a sentence, it creates this parse tree. So it assigns parts of speech to all the words, noun, subject, verb, object. And it keeps a set of hypotheses as it works through the sentence, with a score assigned to each. And at the end, it just chooses the one right at the top with the highest score. And it pops out a parse tree that says what all the parts of speech are, parts of speech is. but then it does a bit of more processing to change that into its own internal representation. It has its own way of representing concepts. And that's all stored in a semantic net, which is really the heart of IGO, where it keeps all its knowledge. And that thing is browsable. You can look what's going on inside. Then there's the Inference Engine that IGO uses when it answers questions. If it doesn't know something explicitly, it can go through its knowledge, through that semantic net and make deductions. And you'll see the semantic net and the Inference Engine are both feeding back into the natural language parser, which is why it's so powerful. All that contextual information, everything it knows, all its history is used to help it to reduce ambiguity in sentences, the same way that we do. And if you ask it a question, it infers the answer within that semantic net environment. And then there's another module that translates that back into natural language and eventually answers. And that's all I want to say there.
Great, thank you.
Okay, I think it's 8:15. That concludes. I'm not sure if there's still some wine and drinks and stuff, but that concludes today's session. Thank you very much for being here and being at our first meeting. And it's great that you arrived here. You were here, at least. Yeah, absolutely. No, that's great. So looking forward to future events and stuff like that. As Paul has mentioned as well, if there's any people interested and you want to showcase some stuff, most welcome to do so. You can just send it to info, send it to me as well, and send it to Paul, and we'll look at that. If you've got any ideas in terms of activities and stuff up here, absolutely, we are ready to do and help. Great, so thanks a lot. That concludes everything. Have a good night. Thank you.
Quite intense. So you can solve
Yes, exactly.
Most people, yes. Normal people, others that we not. Of course, no, yeah. It's obscure. It's been understanding. Disrespect. Explain to this nigga.
The first Friday is already 5 minutes.
I'm gonna carry a pillow around you. Let's give it to chairs and go. This is great, Joe. What's a lot of you prepared for a film? Actually wanted, can't say what I actually wanted to do. I wanted to spell that area with the people on I. Plus 100. Plus 100 points per area. Yeah, actually. I need to update. No, it'll be easy, dude. Let's bring it home. Like, you still gotta get it on. It's okay.